This is a new section and it is an interesting section. I'm sure that you will enjoy it, inshallah. Here in this section, we will learn how to integrate any rational function. When you have a rational function, you know, Shabab, what we mean by rational. When we have a polynomial over a polynomial. So this is a rational function. And the technique that we are going to use, one of the techniques that can be used, of course, is the partial fractions. We will see together what we mean by the partial fractions. Also, we will classify the denominator of the rational function. By the denominator here, we mean the polynomial q of x. We will classify the partial fractions into 4 cases. In the first case, we have when we have the denominator as a product of distinct linear factors. Then when we have it distinct or repeated linear factors. The third case, when we have them reducible quadratic distinct factors, or in the fourth case, repeated, some of them are repeated. Also, we will learn, not today, I think, inshallah, next class, we will learn how to rationalize any fractional expression. We can use substitution that convert the fractional expressions to rationalize, to rational function. And we have at the end exercise number 59 that is mentioned in the syllabus. It is about the substitution, a very effective substitution that can be used to rationalize fractional expressions. So let's start first of all with these integrals, how to evaluate integrals. This is important for you to know why we need to use the technique of partial fractions. So before that, I'd like to ask Khalid al-Zamili. Yeah, Khalid, what do you think? How to find this integral? A. How to find this integral, ya Khalid? Khalid al-Zamili, are you with us? Yes, Khalid, let me ask you this question, ya Khalid. What is the integral of 1 over x dx?
We will substitute, I think it's ln, yeah, ln.
Ln the denominator.
Yes.
Ln the absolute value of x plus c. So because of that, what do you think? What will be the integral of 1 over x minus 2 dx? If you want to use the substitution, Khalid, you will put u equals to x minus 2. What will be the u?
1.
1 dx.
1 dx, yeah, right.
Okay, so this will be u, and 1 dx will be du. So what is the integral of 1 over u, 1 du over this? It will be ln the absolute value of u plus c. So this means that this integral is just ln the absolute value of x minus 2. So there is no need to use substitution. You can skip this step, no need. You can do it immediately here, because you can see clearly you have a function in the denominator. Here you have a function in the denominator. Here you have the derivative. So you have x minus 2, the derivative is 1. So directly, this is just ln x minus 2 plus a constant. Thank you, Khalid. Now, what about the next one, the second integral here? Then the next integral, how to integrate it, Nawaf Tuwajri?
Substitute x minus 2 by u.
Not bad idea, but also it is not good. You can solve it easier than that one, because here what is the problem, Nawaf? Yes, it works, because here you will have also x equals to u plus 2, and you can find, of course, dx will be du. It is not bad. In this case, your integral will be what? Will be
u plus 3 over u.
Over u du. This is plus 1. So this will be u plus 2 plus 1. It will be u plus 3. U du. And you can distribute. You can continue. Yeah. Good. But there is a better idea, ya Nawaf. Thank you. The another idea, Shabab, is to just think about it in 2 different ways. One way is to do the following. This is the one that I prefer. What is my denominator? My denominator is x minus 2, and they are the same degree, by the way. So I can add a hero 0. Is there any problem if I add a 0 to the numerator? No problem.
No.
This is a hero 0. What is my hero 0 here? The hero 0 here is what? I will add 2 and subtract 2. So this is what I'm going to do. What I will have if I did this, I will have x minus 2 over x minus 2 will be 1 plus 3 over x minus 2 dx. And this is similar to what we, if you notice here, Shabab, if you continue here, you will have 1 plus 3 over u du, and it is almost the same. It is the same exactly. Now you can integrate this. What is the integral here, Shabab? Let me ask Naif Rahim, ya Naif, what is the integral of 1? What is the integral of 1 plus 3 over x minus 2? What is the integral here?
Integral of 1 is 0.
The integral of 1 is 0. Plus, what is the integral of 3 over x minus 2?
3 ln x minus 2.
Yes, but now, ya Nawaf, are you sure that the integral of 1 is 0?
Antiderivative x صح.
It is x, ya Naif.
X.
You are integrating, not differentiating. Thank you. Now, also, Shabab, you can use long division. So this is the result. At the end, it will be like this. So also you can use the long division. You know, Shabab, when you have x plus 1, you can divide it by x minus 2. Just multiply by what? By 1. 1 multiplied by this, it will be this. This minus this will be 0. 1 minus minus, it will be plus 2. So you can write the result like this: x minus or x plus 1 over x minus 2 will be equal to the quotient plus the remainder over the divisor. Okay, and this is 3, by the way. The last one.
Yes, 3, yeah.
Okay, now here we are. It is the same. So use anyone you prefer, ya Shabab. Anyone you prefer from these 3 ideas, you can use it. Okay. Now, what about the second myth? The third integral. This one. What about it, ya Rida Al-Junubi? Rida, how to find this integral? What do you think?
Yes.
Give me what you are thinking about. Assume that you have this. What you will do? We will not wait forever. Use long division. You can use long division, by the way. You can use also substitution, but it will be long. You can also put u equals to x minus 2. Then x will be u plus 2. Then x squared will be this all squared. Then you will put it u plus 2 all squared. You will put it like this all squared over u, and here you will have du. You can do it and then expand. It will be u squared plus 4u plus 4 over u. You can solve it, Shabab, but it will be long this way, and I think it is not good here to use long division. So if we wanted to use the long division here, so try to do something. When I'm asking you, Naif, ya Rida Qasdi, you can say anything. You try anything. It is better to try. So now, if you want to use the long division, this will be x multiplied by x. It will be x squared minus 2x. When you subtract now, it will be 2x. Again, you will multiply by 2. 2 by this, it will be 2x minus 4. So you will have 4. Now, this expression, x squared over x minus 2, will be just equals to what? The quotient plus the remainder over x minus 2. You know how to do the remainder. So the integral will be the integral of this. And what is the integral here? It is x squared over 2 plus 2x plus 4 ln the value of minus 2. And I think we have it. Here it is. Now, how to find the last integral, Shabab? This one. How to find the last integral?
Multiply to brackets.
So not bad. At least you did something. I like that. Yes. So don't stop standing still. Do something. So what you said again, please?
Multiply to practice together.
So it will be x squared minus 4 يا فاضل. This is not bad, okay. So then what we will do يا شباب? How to find this integral?
دكتور
using trigonometric function.
Who said trigonometric? Abdullah?
Yes, if we multiply the brackets, we use
What we will do Abdullah? Which trigonometric
it
substitution?
will be x square minus 4. It will be sine,
No.
because of the function cosine square plus sine square equal 1.
No.
Secant.
We will put x equals to what يا شباب?
A secant.
secant 2
2
secant
secant. 2
No.
secant.
2 sine, 2
2
sine.
secant theta. 2
Yes.
secant يا شباب. So this is the substitution that you can use. Yes, you can use this substitution. This is 7.3. You can use that. Continue. But I have a better way. The better way, if you have this integral, if this integral is given for you, what you can do? We will see that together, inshallah, today. We will write it like this. So I will expand it. If I want to find this integral, I will do the following. I will write it like a product. I will factor it as a sum of difference of squares. Then I will say it is equals to, you will be able to do what I'm going to do now, but not now, after finishing this class, inshallah. You will do it like this, plus, here you will have x minus 2. Look, it is not a magic, you will be able to do that. What I'm doing now is called partial fractions. So let me now, I have here 2 and negative 2, so here I will have 1 over 4, and here 1. And here I will have negative 1 over 4. So let me write it here, negative 1 over 4. And here is 1. And the integral will be 1 over 4, ln the absolute value of x minus 2, minus 1 over 4, ln the absolute value of x plus 2 plus c. You can write it as 1 over 4, ln the absolute value of x minus 2 over x plus 2 plus c. And if you did this substitution, you will get the same at the end. But it will be longer. This process, it will be long. Try it, please. Try this one as method number 1 and try this as method number 2 after finishing this section. You will see that this is, of course, much easier. Okay. The question is how I did this step. This is the question. This is the question that we will answer today. Okay. After finishing this section, you will be able to know what I did there, and you will do it as quick as I did. I'm sure about that. Okay. Now let me give you another integral, or let's take one more or 3 more integrals. How to evaluate them? 4. I will add also another one. How to evaluate this integral? Let me ask Muhammad Rumeh. Yeah, Muhammad. Give me your idea. How can you find this integral?
Maybe a long division we can do.
Can we divide here? Good. You can say what you want, Muhammad. So okay. Can we divide use long division here? Look, the degree of the degree. Is less than the degree of the denominator.
Yeah, it's lower.
We cannot use long division. So what you will think about? Remember what you have studied. What could help you here?
Maybe if we
No, Muhammad Rameh, I'm sure he will say something. Yes.
Yes, maybe if we put 2x minus 3 equals to u.
Good. U will be 2x minus 3. So du will be 2 dx. The problem is here, not here. So the problem is in the denominator. When you want, ya shabab, when you have a numerator and denominator, think about the denominator first. So it is here, Muhammad, it is about putting the denominator equals to. If you put the denominator equals to this, what is du? It will be what?
It's 4x.
It is x squared. Not
2x.
It will be 2x minus 3.
Yes.
So what do we have here? We have, in fact, we have here 1 du over u. So you know when you have a function and you have here the derivative of that function, this is so easy. This is just ln the absolute value of the derivative of the denominator. You know that. So in fact here, if this is u, this is du. So it is so easy. So in this case, the result will be the ln of the denominator. So this is not our subject here in 7.4. This is clear. This is 5.5. But it's okay. Now, what about this? Now, if you put u equals to x squared minus 3x plus 2, du, which is 2x minus 3, where it is? We don't have it. So here we have only 1. We don't have the antiderivative in this case. The same here. But here, of course, you can divide. You can use long division, but also you will have something like this after using the long division. So in fact, this integral and another integral, and also this more integral. These integrals we will learn today how to evaluate them. When you don't have exactly, or you don't have the derivative in the exact manner, we will practice and solve some integrals of this type today. But before that, we need to set up some concepts. So what do we mean by partial fractions? What are the partial fractions? When you have a rational function, which is a ratio of polynomials, it is possible to express this rational function as a sum of simpler fractions that are called partial fractions, like this. You know, ya shabab, that if you have two fractions, you know how to make them over one denominator, over one common denominator. So this is the LCD. What we have here is the LCD. You will multiply this by this and this by this, and you will have this. If you simplify the numerator, you will get this. Is there anyone who cannot do this? I think all of you, Shabab. Okay? So you know, if you have two fractions, you can write them as one single fraction like this. Okay? The question is, if you have this, how to write it like that? This is what is called partial fractions. So these, you can now write that this equals to this. Here we are. These two are called partial fractions. Why partial? Because they are simpler. They are part. You have here two parts. In fact, what we did, we just factor the denominator. We write the first factor in the denominator, the second factor, and here we have a constant plus another constant. And if you want to integrate this, for example, if you want to find this integral, so look what you will do. You will just write, instead of this of this rational function, you will write these two partial fractions. And it is easy to integrate this. This is just 2 ln the denominator minus 1 ln the denominator. So easy. The main task now is this step, how to do this. This is what we are going to do today, inshallah. So the idea, if you have a rational function like this, a polynomial over a polynomial, the degree of the numerator is less than the degree of the denominator, then what you can do, just rationalize or factor the denominator, factor it, and it is not difficult to factor. I have noticed that some of you, they have problems with factoring. Try to practice that. So now factor the denominator. Then how many factors we have here? We have 2 factors. So I will have two partial fractions. These are called partial fractions, and it will be here a number over the first factor plus another number over the second factor. These A and B, they are the unknowns A and B, they are called the indeterminate coefficients. We need to determine them, what they are. Like here, for example, in the previous example, they were A, it was 2, and B, it was -1. Here, we need to determine what they are. How to do that? I will give you the idea. We have many 2 methods mainly, but we will use, of course, here the first method. So to do that, ya shabab, what you need to do is just to write this expression as one expression. So let me write it here. So we will write it as 5x minus 3 over x plus 1 times x minus 3. This one, I'm writing this one now, equals to A. Now I will write these 2 fractions as a single fraction. So how to do that, Shabab? We will do by dividing by the common denominator. Now, what you will do to make them a single fraction, you will multiply this by what, ya shabab? You will
X minus
multiply
3.
this by x minus 3, plus you will multiply b by x plus 1. Now notice here that we have the same denominator, So we should have also the same numerator. So we will have 5x minus 3 equals to ax minus 3 plus bx plus 1. Usually we skip this step, ya shabab. We don't need it. We go directly to this step. Why? The same denominator. This denominator here will be the same. Don't worry about it. What you should be worried about is the numerator. So this is the numerator and this is the numerator. Now, what you will do, you will find comparing the coefficients. Now here, what are the coefficients of x? You have ax plus bx. So you have a plus b and x is a common factor. Just expand. It will be ax minus 3a plus bx plus b. So now what are the coefficients of x? They are a plus b. What are the constants? There is no here. It will be negative 3a plus b. Now, I think we have them here. This is exactly what we have. Now, ya shabab, it is a matter of comparing. What is the coefficient of x here? A plus b. What is the coefficient of x here? From the equality of the polynomials, the coefficients on the right-hand side must be equals to the coefficient of x on the left-hand side. So this means that a plus b equals to 5. And this is the constant term, must be equals to the constant terms here. So negative 3a plus b. What do you have here? You have now two equations with two variables. You can solve it by substitution or by elimination. So you can solve it and find a and b. It is not difficult. So a is 2 and b is 3. So you will come back here. You will write just here 2 and here what? 3. So we can have it like this. This is just an idea about how to find the partial fraction. We will practice it more with the examples that we have. In general, if you have a polynomial of degree n, then if you divide a polynomial by a polynomial, you have a rational function. If the degree of the numerator is less than the degree of the denominator, we call it a proper rational function. Like numbers, when you have 3 over 4, this is a proper fraction. When you have it 4 over 3, this is improper fraction. So if you have it as a proper rational function, then it is possible to express f as a partial fraction, as a sum of simpler fractions. But what about if the degree of the numerator is greater than or equal the degree of the denominator? In this case, it is called improper rational function, and you need to use long division. Divide q into b by long division, and you will have, by the division algorithm, you will have this. You will have the quotient plus the remainder over the divisor. Now again, here you will have the degree of r, the degree of the remainder must be less than the degree of the divisor. And you will go back, if you have this something, you will do that the opposite. You will do, of course, it is possible after that to express it as a sum of partial fractions. Let's take this example. Now, how to find this integral, Shabab? What should we do? Is it rational function? Is it polynomial over a polynomial?
Yes.
The answer is yes. Now, is the degree, what about the degrees? The degree of the numerator is greater than the degree of the numerator. So what should we, for the denominator? So what should we do?
Log division.
We should use long division. So here, because of that, we will use long division. Log, you have x cubed plus 0 times x squared. There is no coefficient here for x squared. Now, you will you need to multiply by x squared. I think, Shabab, you need to revise the long division if you forget it. Now multiply by x squared minus 1. So this is what you have. Subtract, you will have 0 minus, it will be plus x squared. Bring this down. Now you need to multiply by x to have x squared. Cancel, you have 2x. Multiply by 2, you will have. Now you will stop because now the degree is 0. This is of degree 1. We will stop when it is of degree 1. Now by the division algorithm, what we will do, we will say like this, what it was x cubed plus x over x minus 1. This will be equals to the quotient, x squared plus x plus 2 plus the remainder over the divisor. Okay, now just if you want to integrate this, if you want to find the integral, just you will say that the integral of this equal to the integral of this, like this. Here we are. Now to find this integral, just you need to evaluate this integral, and of course it is so easy to evaluate this integral after dividing the denominator by the denominator. X cubed over 3, x squared over 2, 2x, 2 let the absolute value of x minus 2. So we didn't here use any partial fractions. We were lucky, just the long division is enough. But sometimes it will not be enough. Sometimes you need to do this, something like this. So if we have the remainder over the divisor, it is still need not direct integrated function. We need to do some factoring there or some work. So if the denominator qx can be factored as a product of linear factors, you know linear factors like 2x minus 3, x plus 1, these are linear factors. Or irreducible quadratic factors. What do we mean? Something like this, like مثلا x squared plus 4. This is irreducible quadratic. It is, of course, it has no real zeros because the discriminant is negative. So you cannot factor it anymore as a product of linear factors. By irreducible, we mean that it cannot be written as a product of two linear factors. The polynomial has no real zeros, no real roots. Like, let's take, for example, x to the power 4 minus 16. Can we factor this? We can factor it as a difference of squares. So it is x squared minus 4 times x squared plus 4. Also, this one can be factored as a product of two linear factors, some difference of squares. But this one, you cannot factor it. So this one is irreducible quadratic factor. These are linear factors. So these two are linear factors, and this one is quadratic, irreducible quadratic factor. Then if we can express, if we have this situation, we can express the rational function r over q like a sum of partial fractions of this form. If the denominator is linear factor, we will write here a constant. Look here, what is the degree here of the denominator? It is 1. So what we will have here is of degree 0. It will be 1 degree less than this. Here, this is of degree 2. So we will have here linear. We will have it here of degree 1. And so on, of course. Let's take the first case. The first case when the denominator is a product of distinct linear factors like this. So you have a linear factor multiplied by a linear factor multiplied by a linear factor. Here we have k linear factors. So because here we have k different linear factors, we will have k some partial fractions. We will have k partial fractions. If you have this situation, you will write it like a constant over the first factor plus a constant over the second factor and so on. These are the constants that we are going to find after that. Let's take an example, Shabab. The first example is about evaluating this integral. We are lucky here because the denominator is already factored. If it is not, you need to factor it. Okay? What is the degree of the numerator? It is 2. What is the degree of the denominator? It is 3. So here we cannot use the long division. So we should think about, can we integrate it directly? We cannot. If we cannot, we can think about now partial fractions. I have a rational function, polynomial over polynomial. Now, how many linear factors we have, Shabab? We have what?
3.
3. So how many partial fractions we have?
3.
We will have also 3. So now this, we will write this, which is now r over q. This is r over q. We will write it here. This will be equals to a over x minus 1, a over the first factor. Another constant, here he call it a1, a2, a3. It's okay, you can call them a1, a2, a3. But let's take ABC, it is okay. So we will have a over x minus 1, b over x plus 1, c over x plus 2. This equals to this, but we need just to find out what is a, what is b, what is c. How to do that? To do that, as I told you, Shabab, you will just make this as a single fraction. So if you try to make these three fractions as a single fraction, you will make them over the same denominator, but we will skip this step. Okay, and you will have here the same denominator. Okay, the same one. So no need to focus on the denominators, they are the same. Now focus on the denominators. What is the denominator here? The denominator here is x squared plus 4x plus 1. Now here, to make this a shabab a single fraction, what we will do? We need to multiply a by what? We need to multiply a by, it has x minus 1. So we need to multiply it by x plus 1 and x plus 3. Am I right? To make it over the same single fraction. Now for b, it has x plus 1. I need to multiply it by x minus 1, x plus 3. Okay? What else? Plus c. C, it has x plus 3 in its denominator, so it needs this. So it needs x minus 1 times x plus 1. Good. So now this will be equals to what? Forget about the denominator. It is the same as I said, Shabab. So this is x squared plus 4x plus 1. The denominators are the same, so also the denominators must be the same. And here we are. This is exactly what I did. Okay? Now, it is now, there are two methods, the general method and the short method. Of course, I'm sure that you will prefer the short method. They are equivalent, of course. Now, what you will do, ya Shabab, you will expand this. This is the general method. So what you will have here, you will have x squared plus 4x plus 3 and so on, okay? Now you will compare, you will find what are the coefficient of x squared. What are the coefficient of x squared? A, you will have A. This is now, what I'm doing, I'm looking for the coefficient of x squared. So it is A plus B plus C. Now, what is the coefficient of x squared here? It is 1. So this A plus B plus C must be equals to 1. What are the coefficient of x? What are the coefficient of x? 4A plus 2B. There is no x here, so just like that, plus 0. So now this one, 2A or 4A, this one, 4A plus 2B, let me write it here, 4A plus 2B must be equals to what? The coefficient of x here, what is it? 4. And last thing, Shabab, is the constant. What is the constant here? 3A minus 3B minus C. Now this one must be equals to what? Must be equals to 1, the constant here. In this case, we have a system of a linear system with 3 equations and 3 unknowns, 3 variables. Do you recall how to solve this from MATH102? You can use Gaussian elimination, you can use the augmented matrix, you can use the inverse matrix. There are many methods to do that. So it depends on how good you are in solving such system, okay? So now, if you did solve the system, this is what you are going to have. This is A, this is B, this is C, okay? This is in fact the main task, and it will take your time. And I will show you, and this is the general method, but I will show you a short method to do that, but not now, after the next example. So now, ya Shabab, I did find A, B, and C. What I will do, I will just substitute here. So this integral will be equals to the integral of A over x minus 1, here it is, a half over x plus 1, a fourth or negative fourth over x plus 3. Now this integral is easy, just it will be 3 over 4 ln the absolute value of x minus 1, the absolute value of x plus 3, the absolute value of x plus 3, plus K. Do you notice something here? We change what? We change the constant of the integral. Why?
Because we have C already.
Yes, this is of course one of the beauty of the mathematics. It has to be consistent. If you said C here, do you mean this C or another C? Okay, you're right. We already used C here. Good. So let me show you, Shabab, not for this example. I will come back to this example, but let me show you another method to find this. And I have another short method. So the another method to use to find A and B, because I'm sure that all of you, let's say most of you, they don't like to solve three equations with a 3-variable system. So what you can do, what is the alternative method? The alternative method, ya shabab, is you have to do this step. So up to here, you have to do this, but no need to do this. So you can cancel these 2 steps. Just stop here at this step, okay? So what you can do here, if you write this, multiply A by the other factors, B by the other factors, and so on. Now you need to ask yourself, what is, when this one will be 0, Shabab? What is the 0 of this factor?
1
X equals what? 1 here and
minus
here.
1 minus 3.
So how many zeros we have? We have 3 zeros, okay? These are the zeros or the roots of the, so what we will do, we will list them here. Look, x equals 1, x equals -1, x equals -3. These are the zeros of the distinct linear factors. Now what we will do, we will go to this equation here and we will substitute. Now, both x equals 1 here, what you will have? You will have 1 plus 4 plus 1. Here it is. Okay? Both x equals 1 here, you will have 2. Here you will have what? 4. If you put x equals 1 here, because we have x minus 1, it will be 0. This will be 0 because we have x minus 1 there. So now simplify. This will be 6. This will be 8a. Is it clear, Shabab? Do the same now. Both x, so this means that a is 3 over 4. And it is 3 over 4, look. We did, it is 3 over 4. The another thing that you will do the same with x equals -1. If you put x equals -1, here you will get 1 minus 4 plus 1. Here, if you put x equals -1, this will be 0. Here you will have b times -1 times 2, and this will be 0 because of if you put x equals -0. So you will be able to find out what is b. So b in this case will be -2 over -4, which will be a half. If you put x equals -3, which factor will be 0? This will be 0. This will be 0 because we have x plus 3 there. So if you put x equals to -3, you will be able to find what is c. So in this case, c will be equals to -1 over 4. I think you like this method, Shabab. Did you? It is much easier than the general. I have a better method. Better than this one and this. It is a shortcut from this method. Let me show you what is it. Let me go back here. I told you, Shabab, you can stop here. Even in this method, you don't need this step even this step, you don't need it. So the another method, which I call the covering method, it is much easier. Now, what is the coefficient of x minus 1? What is the denominator of a? What is the denominator of a? It is x minus 1. So cover it here. Forget about it. Now a will be equals to what? What is the denominator here? What is the 0? It is 1. Here it is -1. Here it is -3. Now to find a, just substitute here by what? By 1. So a will be 1 plus 4 plus 1 over 2 times 4. Am I right? It is 6 over 8. It is 3 over 4. Just like that. What is b? If you want to find b, ask yourself, what is the denominator of b? It is x plus, cover it here, forget about it. Substitute by the 0, substitute by -1. So it will be what? 1 minus 4 plus 1 over, if you substitute here by -1, it will be -2 times, if you substitute by -1, you will have 2. So you will have what? -2 over -4, it is a half. So this is b. If you want to find c, just ask yourself, what is the denominator of c? It is x plus 3. So cover it, forget about it, because I cannot substitute by -3, of course, there. Now, what we will have, when you substitute by -3, you will have 9 minus 12 plus 1 over -3. It will be -4 multiplied by -2. Simplify, you will get, of course, the same result that we have before. Here we are, Shabab, just check the A and B and C values. This is A, this is B, and this will be C. I have another method with this method here. Here it is, this one. Use the partial fraction to evaluate this integral. So what we will do, Shabab, the degree for the numerator is less than the degree of the denominator. So we will try to factor the denominator. Then you need to factor it again because you have quadratic here. Quadratic until you can write it until you have irreducible quadratic factors. Now, how many linear factors we have? 3.
3.
So this means that we have also 3 partial fractions. So we will have some number over x plus another number over x minus 2 plus another number over x plus 5. Then our task now is to find what is A, what is B, what is C. Okay? What we will do, as I told you, I will ask myself, what is the coefficient of A? What is the denominator of A? It is what? X. I will cover it. And I will ask myself, what is the 0 of this factor? It is 0. What is the 0 here? Is 2. What is the 0 here? Is -5. So I will substitute here by 0. To find A, I will cover it, then substitute by 0. This is A. To find B, cover its factor, cover its denominator, x minus 2. Cover it, forget about it, and substitute by 2 instead of x. The same issue can be done for the last partial fraction. Its denominator is x plus 5, cover it, and of course substitute by -5 because the 0 is -5. You will have C. And in this case, you can write this rational function as a sum of 3 linear factors or 3 partial fractions with linear factor denominators. And the integral will be so easy. You will just integrate this. What is the integral of 1 over x? It is ln x, and this is -2 over 5. 3 over 7, ln the denominator. -1 over 3x plus 5 plus c. And here we need to change this to k. Yes, because it is not c anymore. Any question, Shabab? I wish that this process is clear. Let me give you another example. Oh, it is an exercise. This exercise, the degree of the numerator, sorry, it is greater than the degree of the denominator. So we should start here with what? With long division. So after doing the long division, look what you have. And next you will integrate both sides. Now the integral of this will be the integral of 2x, and this is so easy. Now the question is how to integrate this. And I think we did this in the previous slides, yes, Shabab. Just go to slide, I think number 4. We did write this as a sum of 2 partial fractions. Here they are. Now it is so easy to continue this integral. Again, I think we don't use it here, but it's okay. You can use it C or K. I have another example here. The degree here of the numerator is less than. So you can use the long division, but before that you need to factor the denominator. Take x as a common factor, then factor this. And ya Shabab, you have to factor because I have noticed that some of you, they are using the quadratic formula. Please, ya Shabab, you need to practice more the factoring process. Now, how many linear factors? All of them are distinct linear factors. So we will now write this as a sum of 3 linear factors. Now, what is mentioned here is the general method. But as I said, ya Shabab, you can use the another method that I told you about. Okay, so let's continue. This will be, of course, how to find the integral. How to do this? Let me show you how to solve it by the another method. So what I will do, which method now you prefer, Shabab? We have the general method, or let's call the substitution method, or the covering method. Yalla.
Covering.
The covering method is the best, but you be careful, Shabab. This method works only if you have distinct linear factors. When we have different linear factors, it doesn't work in general. So here we are. I think we don't have time to do that. We will do it inshallah next time. Just here, if you want to find A, cover this and substitute by 0. You will be able to find what is A. You need to understand, Shabab, the idea behind it to make sure that you will not do any mistakes. Thank you and see you inshallah tomorrow.